Good morning, everyone. It is my distinct pleasure to introduce a renowned expert in the field of agronomy and weed science and weed ecology, Dr. Anita Dille. So she comes from a rich agriculture and educational background. She got her PhD from University of Nebraska-Lincoln, and both her master's and bachelor's from University of Guelph, Ontario. And her research is critical for the state of Kansas, focusing on understanding the impacts of local weed species on vital crops like grain, sorghum, corn, and wheat. She also works on understanding the spatial distributions of weeds, examining how they correlate with soil parameters. And also she works over the influence of cover crops on weed management. Her work is also focusing on investigating the effects of herbicide efficacy and population dynamics. She also works to study the palmer amaranth competition in corn and grain sorghum. For those who don't know, palmer amaranth is like a very big weed in Kansas and in grain sorghum and corn too. And she's also a very good educator. As an educator, she's very passionate. She's committed to train future agronomy students in the field of integrated weed management and advanced weed ecology. And I'm taking one of her courses this semester, and I really enjoyed throughout the course. And she helps us to provide the undergraduate student a practical approach in identifying weeds and managing them. So I would like, please join me to welcome Dr. Dille and have a great talk. Thank you. Thanks.
So good afternoon, everyone. I think we switched over to past the 12 o'clock time slot. Thank you so much for inviting me today to come and talk. Megan sort of left a wide open topic area for me. She said, you know, what top 3 things should everyone know about weeds? I'm going, are you kidding me? That's narrowing it down. So it's kind of narrow, but it's going to be wide open. I'm thinking I may have about 30 minutes of material. So if you want to interrupt, you have questions or other ideas, don't hesitate to do that. Part of developing this talk is reflecting on some of the other roles that I also have had in the area of weed science. I just finished my stint as president for the National Weed Science Society of America organization. And so that again is a 4-year commitment for the national level. So it's Canadians, US, as well as international folks that are involved in weed science. And so then I got exposed to a lot of different areas and topics. So I'll mention a little bit about, you know, some of those things that people are saying are the emerging issues or the areas, or as I also said, this is equal to our opportunities. So maybe giving some ideas of where else you, as maybe not weed scientists, might find a place that you could help us deal with some of these weeds. Many of you have recently interacted with me as you're trying to sign up for classes, right? So that's who it is. I'm on the other end, and I tried to respond as quick as I could. We're making some changes in how you guys sign up for those research hours because I'm not your supervisor. And you used to all sign up for me and it looked really good. I had 50 graduate students. And it's like, no, I don't. And so we've shifted to making sure that you're connecting with your own faculty advisor or co-advisor or something like that. I am going to make a change though, and I'm not going to be the instructor that you have to ask permission for. But now that people have practiced, you should be able to sign up, see your professor and sign up for that one. So as I start updating classes already for next year fall, right now, I'm going to make sure I change that so that I don't have to, I get to meet all of you, but I don't want to have to do that. So we'll make that better. Same for the summer. I have to make those changes for the summer. So yeah, I'm going to describe sort of a range of things I do. I do teach our undergraduate weed science class as an introduction, then an integrated weed management. So sort of that second level, how do I now think about managing? And then every other year, a graduate level ecology class. We also coach a weeds team. And so if anyone's interested, it doesn't have to be a weed science student, but then you get to practice and delve in, and another great way to connect with the industry because it's hosted and run by a lot of our industry partners. So through Corteva or Syngenta or Bayer or BASF or Valent, those companies then host the contest. So we get to do that. So a lot of opportunities to see if you like weeds, or to expose yourself and get practice in those areas. So. Make sure that's working. There we go. I wish this was the case, but I could hit the Staples Easy button and ta-da, I've got weed management. But I'm also glad it's not like that, because otherwise then I wouldn't have a job, right? We know we got a lot of aspects of weeds. So for a while, we almost thought this was the case. Folks that are familiar with Roundup Ready cropping systems. So I've been here at K-State almost 24 years. Next week, it'll be 24 years that I've been here. Prior to that, I was at Nebraska. I was doing some really fun work on site-specific weed management. I'm gonna go map weeds and then tell you where those weeds are and go spray them. And then all of a sudden, the Roundup Ready cropping system came out and was like, who needs to know where the weeds are? Roundup works on everything, kills everything, just go spray. Okay, I've been waiting 20 years to get back to that point of where I can now go map weeds and tell them where to spray, because glyphosate has sort of fallen apart and we have a lot of resistant weeds, and now I need to learn those again. And so I used to have sort of these eras of weed science, before Roundup, during Roundup, and now where we are afterwards. And we've got a lot of challenges. So that's where some of these emerging issues may be coming up as we talk about it. As I started thinking about it, I have my 3 R's, right? Not like your fertility recommendations, or even on my pesticide application side of things. But these were my 3 sort of big issues I wanted to just talk about today a little bit. First one is resistance. The challenge that we do have with herbicide resistant weeds, and then also the exploration of how we develop herbicide resistant crops and use that. In thinking about the national level in my Weed Science Society hat, I learned a lot more about and the challenges that we have with regulations in doing some of our weed control work too. And so I want to just spend a little bit on EPA and their role and the challenges we're facing with this act called the Endangered Species Act and how those interact. And then sort of one of the fun new areas, like I said, I did this about 25 years ago as my PhD. We get to come back and recognition of my weeds. And I've got neat artificial intelligence approaches to doing that, neat new application technologies, real advances in that area. And so we'll share some of the research that my group has been doing in those. So those are the 3 kind of emerging issue areas and opportunities I think that we have that I want to explore. So the first one, resistance. What does this look like in the time that we have? So Dr. Ian Heap has a really awesome website. This is where all the weed scientists upload any record of a resistant weed that and so this is open to all weed scientists around the world. Weedscience.org. So if you're ever looking for information on a species, a chemical, what's resistant, that's the place to go find it. Right now, this is sort of a summary of the global increase of unique resistant cases that we have. There's 523 unique cases of herbicide resistance out there right now. There's 269 different weed species with multiple different herbicides that they are resistant to. These are happening in 99 different crops and across 72 different countries. So when we think of herbicide introductions, that started in about the 50s. We really didn't have it. There was one case of herbicide resistance, they think. This was field bindweed to 2,4-D. I don't think 2,4-D ever controlled field bindweed. That's our other Kansas flower, if you think about it. But really right before the 1970s is the first case of herbicide resistant weeds in atrazine, atrazine resistance. And it's just been a steady increase ever since. Mainly because once we recognize this resistance trait, it opened up a whole new area of weed science where we're now like, why is that plant resistant? So diving deep into the genetics and understanding the physiology of the plants and learning that. And so we've had a steady increase. I couldn't find it, but if you have a map of the US and the cases of resistance mapped on that map, Kansas is like a bullseye in the middle. We have almost the most resistant cases. So part of that is we're very diverse in our cropping systems, right? As we look east, west, north, and south. The others, we got a great weed scientist and Dr. Jugalam. So if you think you have a resistant weed, she'll figure it out and we put it on the map. So we just happen to have a lot of them because we've got someone that's looking for them. But that's a pretty significant issue, and it's continues to increase as we discover them and document them. For those that are a little bit more into what some of these herbicide modes of action are, you can see sort of the pattern. So the blue line is the atrazine example, and so a pretty steady increase since the 60s all the way through, and we're still adding to those. A later product that was introduced in the mid 80s. Within 4 or 5 years, we discovered resistance, and it just shot up, and we'll continue to find that. Glyphosate, I mentioned that one. Glyphosate resistant crops were introduced in about 96. Within 3 years, we had finally identified resistant weeds, and that continues to creep up. And that's a group 9 is the glyphosate, the light blue lines. We have group 4s. This is our 2,4-Ds and dicambas. They're growth regulator herbicides. They are the ones that we discovered first to use. They've been around a long time with a steady increase in resistance. So a lot of these, this is the weeds side. We have crops that we've also then developed to have resistance to those particular traits, so I can continue spraying these products safely on those crops, but that also then increases the pressure of the herbicide on those crops and on the weeds. So we're selecting more and more resistance. So in some of these, we continue to see those numbers increase because we've used those products more often, but just some of those key groups there. The other challenge is that they aren't just resistant to one herbicide, but they're often stacked as a weed species with multiple herbicide traits. So this blue line here at the top is maybe 2 traits. Often you could look at a product and product 1, product 2, I can't spray either one because the weed will survive, but there are some that are up to 11 sites of action in a given population. That doesn't leave you with too many choices for weed management. So that's part of our challenge and opportunity is I'm not gonna be able to spray my way out of it. But how do I think about my integrated weed management, my other tactics, the other practices that I can use to go after those weeds? A phrase used as many little hammers. I can put out a big sledgehammer, but I'm only gonna hit, the nail on the head once, and maybe I'll get it knocked down. But if I go after it many times with many different strategies, I might do a better job of managing those weeds. So that's part of in my teaching. I want to make sure that we're covering the full gamut of things so that students understand, what we can go after our weeds with on the herbicide side. Which crops are we finding these weeds in? Again, depending on the products, but in reality, wheat is one of the top crops that has the most species resistant in it. Corn following pretty quickly behind, rice and soybean aren't too different from each other. And then we've got sort of a range of other ones. I'm not sure why wheat and winter wheat are that different in that. But again, you can just see we've got many resistance issues in the diversity of crops. And so that increases our challenges there as well. Here's the list of some of the weeds. This is just for glyphosate resistance. So again, found early on in the 90s in the US, horseweed, mare's tail was one of the first ones discovered in 2000. And since then, it's just been a steady increase of identification of those weeds that have that resistance. So I put the scientific names up for a more international audience. My students don't want to necessarily learn those, but when you get to the weeds team, you do. So there. Manogna mentioned a couple, so I'm going to talk a little bit about horseweed as one of our weeds that really drive what we're doing in Kansas. The other one is Palmer amaranth. So that was discovered to have resistance in the mid 2000s. Where's my other one? Kochia is the other early on. So we've been dealing with these for 15, almost 20 years already in regards to resistance issues. So when I think about resistance, what are the opportunities for people in any area of the science? One is just continually surveying for these resistance issues. Part of this is to what extent I may have discovered it in one spot. Okay, I know I've got resistance, but I don't know where it's going to and who else has to deal with it. And so if there are opportunities to survey larger areas, go to farmers' fields and collect populations and discover how spread out is this issue. So that's one element. that we need to look at. For example, what Dr. Jugelum's been looking at, and we explore this is, are they target site resistance mechanisms or non-target? If it's a target site, that plant could potentially be, the gene changes one little bit. It's absolutely resistant to that herbicide. I could spray, 10 times as much product and won't touch that weed. The challenge comes in when we're looking at non-target site resistance, which is a newer metabolism based. We've got a lot of enzymes in our plant that break that down. Any chemical gets applied, the weed has figured out how to get over that. And it may be a target site for one herbicide. And it may also then be resistant to a new herbicide that's never been exposed to that plant because it's using the same mechanism to break it down. And so we may think it's not resistant because I haven't screened it for that, but because it's either a cytochrome P450 or a GST mechanisms that break foreign materials down, it's already resistant to a herbicide that it hasn't even seen before. And so that introduces a really big challenge in regards to how do we manage that and understanding it. So a lot of aspects on the genetics, as well as on the physiology of our plants to understand how they're reacting and how then we need to manage them. I'm just putting the words up here. I don't understand these really at all, but there's a huge area and interest in all the omics. And so again, for folks in plant breeding, physiology, that area, you may get deeper into this, but these are opportunities to explore and describe the genomics of weed species and identify traits and be able to then help us with either new herbicide, potentially new sites of action, new places in the plant to go after. How are these different traits expressed and are there opportunities? And so this is a huge new field that's really getting developed. And we're starting to look at candidate key weed species and describe those more fully. And so opportunities there for folks to get into that. Through that, maybe we'll finally come up with a new site of action herbicide. We are not, for a long time, that's not the direction we've been going. We haven't had a new herbicide in like 25, 30 years. It takes 10 to 15 or longer years just for a company to find a product and maybe it'll work out in the field. It's usually stopped at a point because a lot of those are toxic to other things. So, or an environmental impact. So even through their screening, it may work great to kill weeds, but it might also kill something else that we don't want. So then it's off the shelf and almost in the, in the back pocket, far, far away. So opportunities with some of this science to allow us to discover new sites of action. The direction most companies have been going is to developing crop cultivars with stacked site of action traits. So instead of just 1, 2, or 3, we're looking up to 6 different sites of action in a given crop. That gives a grower an opportunity. These aren't resistant to all those, but that they could safely apply a diversity of products. The challenge for a while has been making sure, if you hire the co-op to come and spray, they need to make sure they know what traits in your field, because if they mix the wrong thing and spray your field, your crop is destroyed. And so by putting multiple stack traits in there, you're giving some protection or insurance to those growers that the company may not spray the wrong thing on there, but you'll hopefully still get good weed control. But this is definitely an area that we're looking at, that the companies are exploring in adding those extra traits. Reflecting on this too, some of the work Dr. Jugelum has been doing, not just understanding targets of why the weeds are resistant, but she is also exploring opportunities to add herbicide resistance to wheat and to grain sorghum, using non-GMO kind of procedures in order to maybe add that for our producers in the state to have some more weed control options. And just to give you a little up close picture of some of those weeds, these are really what's driving a lot of the weed management decisions in the state. And often they do have resistance. And so kochia, these are really tiny little seedlings. They come up in February. So as soon as the snow melts and the soil's a little bit warm, they're up already. Growers aren't even thinking about the crop stuff, but that is really early weed. So we need to be ready for it. This is a nice picture of Palmer amaranth, healthy growing. I got a little velvet leaf in there too. But clearly, that's a challenging plant from the top side. You can imagine they're taller than me when they get going. And then this is Mare's tail or horseweed that should be up and coming in the field right now. So winter annual. and they're tiny. But come in the spring, they've already got lots and lots of leaves on there and make it very difficult to control, and also resistant. So those are just some of those driver weeds that we are going after and wanting to manage. So as an opportunity, we've got just increasing resistant weeds, a big management challenge, increased cost, and looking at multiple traits that are there. And so lots of opportunities in both basic and applied weed management research in those areas. Okay, so diverting this a little bit, I wanted to introduce this other issue in the regulations. Part of the challenge, and so what is EPA, what do they do, and then how does this link up with this Endangered Species Act? One of the challenges we've had in the last 10 years is with some of the traits that have gone into our crops like dicamba and 2,4-D. And there are a lot of other crops that are very sensitive. So if the herbicide gets sprayed on the crop and it moves off, we see a lot of damage on neighboring crops. And so EPA and pesticides have had to do an incredible amount of work to try to come up with better recommendations. How do I use these herbicides in so many crop acres and not cause injury on susceptible crops or neighboring crops, or minimize it, especially because all of a sudden there's thousands and thousands and thousands of acres getting these products, and we're seeing offsite impacts. Part of the offsite impact is that we are not supposed to endanger any species that may be on this act. And so we might accidentally have that herbicide move not just onto my neighbors, but onto these other species or habitat for a species that we're supposed to protect. So let me give you a little background. Again, this was reflecting on sort of my learnings in the WSSA. So the EPA has an Office of Pesticide Programs. They basically regulate the manufacture and use of all pesticides in the US, not just herbicides, but all insecticides, fungicides, rodenticide, anything. And they establish a maximum level that you're allowed for residues on food. They are basically regulating and making sure that these acts are followed. So one's FIFRA, which is our Federal Insecticide, Fungicide, Insecticide, and Rodenticide Act. PREA is the Registration Act. And then there's also these ones that have come up. One is a Food Quality Protection Act, Federal Food, Drug, Cosmetics Act, and then the Endangered Species Act. So they've got a lot of responsibility across our food, across the environment, across healthful things they're doing. So their challenge was they regulate the pesticide side, but they also have to do that all within what's known as the Endangered Species Act. They regulate a herbicide, but they got to make sure that it's not affecting that. So what is the ESA? So this is a conservation of threatened and endangered species and their habitat. So my herbicide may not hurt the animal, but if it hurts the plants that they're living in, then that's not supposed to happen. So we need to understand if I'm spraying a herbicide that it's not moving onto a habitat where this threatened animal is. So there's a lot of information online. So they basically are responsible and making sure that a pesticide product can be registered for a use. Part of that, make sure that the listed species or the habitat's not affected by that product, and that if it may affect, and that's pretty kind of hedging their bets. It might hurt it, it might not, I don't know, but that would basically mean I can't use it, or it has to get fully evaluated even more so. So in Kansas, we have, I'm of course interested in the plant side of things. We have 2 that are on the endangered list in Kansas. There's 16 endangered or threatened animal species. You can find all of those, but there's 2 threatened plant species. One is this Mead's milkweed. That's the picture on the top there. And then there's really pretty orchid known as the Western Prairie Fringed Orchid. So that's here. And what I wanted to do was just highlight, and it was hard to find, but where might these plants exist? And often they just label a county. And so if I'm, a corn farmer in this county, I might not be able to use XYZ products just because that Mead's milkweed might be there somewhere. And so the WSSA has been working really hard and communicating to EPA and getting data to say, okay, Mead's milkweed doesn't exist in my cornfield, it's in this riparian area or in this pasture area. And around it are cornfields that I will do the right things in. And so how can we break it down into more site-specific information rather than just this county and you can't use it? And so that's something that the WSSA has been really working hard to try to get more information back to EPA and understanding this ESA. So this was just a map to say, okay, this is Missouri. I couldn't find a Kansas map. So basically it's highlighted that these are counties that have the population in it, and we do have it here on the eastern edge of the state of Kansas. In a couple counties, this map makes it look like it's the whole eastern side. Well, that's a pretty good crop production area, and if I use, say, extend soybeans, which I spray dicamba, and that's controlled broadleaf plants, I could potentially injure that, but I don't know exactly where it is. And so a lot of work needs to be done to document those two sides. The other was this prairie fringed orchid again. Here's Kansas, a couple counties here in the northeast, part getting on the edge of the tall grass. But again, it's just labeling the county, and we need to make sure that we're understanding where exactly it is versus the whole county, and that we then recommend back to EPA. This is how we can use these products and not be excluded from a farmer being able to do that. So the opportunity I want to highlight behind this, for anyone that might be interested in, how do these government organizations come up with more information? So opportunities to get into some policy, kind of understanding policy and how do you respond and how do you write things. And so I signed off on a number of these kind of letters, but the Weed Science Society is the overall one, but we have affiliates with our Northeast, North Central, Southern, Western societies, and with the Aquatic Plant Management Society. We have a person who's in Washington, DC, as our science policy person, and he sees these issues coming up, and then he pulls people together and write responses to some of these regulations that are coming out. So this is just the first part. They basically wrote to the director of the OPP program for the EPA. And this was basically, they had put out a herbicide strategy framework to reduce the exposure to these species. And we said, whoa, there's a lot of stuff in here. We need to give you more science behind it. And so this thing is 34 pages. I just put the first intro on there, but lots of excellent information. And in the WSSA, we actually hired 2 interns or fellows that work closely with our science policy person and get a chance to explore some of these things. So if anyone's ever interested in that, I think it's the same thing through ASA. They have congressional fellows, the Tri-Societies or other places. But if you're ever interested in something like that, there's some ways to explore and share your science to those that may not have as much about it, and how do we help that? Okay, so the last, any questions on that? Or opportunities or neat things? Just going back to thinking about those, those wildflowers. My husband and I, Russell, most of you know, maybe know Russell from the farm, but we farm just north of town, and part of our land, we have a native grass area. And I just love walking around there. Every week there's something different flowering. And so always on the lookout. So for me, that's a pretty big impact of, oops, wrong way. Thinking about when I spot something new and different, and I take a whole bunch of pictures. This isn't mine, but our crop ground is right next to it. And so we're making decisions and making sure we're not, herbicide and the control we want stays on the field and not going into our native grass area. So I think most farmers are stewards and know that. But EPA is just the blanket, hey, this is what we got to do to protect everything. So that restricts what we want to do. Yeah.
How they propagate, like the seeds or the?
This will probably be a combination of both. A lot of them are perennials. And so then they'll have below ground structures. But in this case, even as I look at it, I only see a single stalk for that. But the milkweed, again, is a perennial, but it does have some flowers and seed. But it's a fairly weak kind of milkweed plant. And so again, it struggles in some of those environments. So I don't think the populations are really high. And so they're looking at how to maintain high enough populations, but also not add to it. So that's why they're on the endangered list. Good question. Okay, so the third kind of issue and my third R, recognition. How do we go out and see weeds and how do my vision and observing of a weed get translated into maybe an artificial way of doing it, because it's a lot easier to fly a drone or fly, you know, a sprayer across the field with cameras to ID those plants than me having to go do that, right? And so we're really working, and a lot of different groups are exploring that. And so I wanted to spend a little time on a couple things that our group has done. So Isaac Barnhart, he's been working on his PhD. He's going to give a talk on some aspects of this tomorrow during summer. But one of the projects we had done is he was using open source object detection programs that are available online. Face recognition type of things, for example, but instead we're looking at, can I recognize my Palmer amaranth in my soybean? And so the one is YOLO V5 was what we were using at the time. There's already up to 7 and 8, I think, out there, but it says you only look once. So the idea is I look once and I can figure out what it should be. And so he started with lots of pictures of corn, soybeans, Palmer amaranth, different growth stages, put all these what they call bounding boxes on there to say, okay, this is Palmer, this is Palmer, this is Palmer, this is soybean, this is soybean, this is soybean, feed that into the program, and then have a test picture to see how well it learned what those weeds were and then identify what they are. Yeah.
He trained that manually, like selecting pixels.
This he did all on by hand. 1,000
You know?
images at least, plus multiple boxes on each one. So yeah, he was hiding out in his office for a while. We do have it published, so it's like, cool, you know, all that work came, you know, made sense. But this is what, so this was then a training picture that he put through. And we had about 85% accuracy, so not too bad. But this is a picture that shows, well, dude, this is velvet leaf. Why did you say that's Palmer? And this is carpet weed, not even, but you know, the other ones were correctly identified as Palmer amaranth. So there's still, you know, those false negatives. I got a weed, which is good. I just didn't tell you which one it is. And so that's, you know, part of the development of what we want to do. But so this is one example of how do we use facial recognition, weed recognition to potentially go in and once I know that, maybe I can create a map. I can put a herbicide application out there and make some of those decisions. And so this is one area that people are really looking at. You know, can we add more weeds and really train them up to understand this is the color and the dimensions and the shape and orientation, so that you can say this is Palmer amaranth. The other part of what we were interested in, and Isaac really wanted to explore, and so we've been able to do that, is using, they've changed the name a whole bunch of different times, but this is One Smart Spray. This is a Bosch BASF collaboration, joint venture, I should say. Bosch is the equipment side, BASF from the company side. Zarvio is another name of their spatial thing together. So we've had the opportunity to work with Bosch BASF out of Seymour, Illinois, where they built and developed the spot sprayer that we're using in our research, together with folks at Nebraska, Wisconsin, so the 4 states. A number of us are looking at different ways of putting this sprayer out. In general, it's hard to see on this one. I've got a video that might show it a little bit, but these little white boxes on the top here are cameras. They are facing forward. They see green, tell the computer that there must be a weed there, and then it'll turn on an individual nozzle to spray that weed. Doesn't matter what the weed is. They just wanted to get this equipment out there and start working. Eventually, we'll get it smart enough to know, okay, it's this weed or that weed. But right now it's like, hey, it's a weed, I need to spray it. So we can use this in what they call green on brown. So like a fallow scenario, anything green will get sprayed. And this also works in crops, so green on green opportunities. Basically, it says, this is your crop row. I'm not going to look there. I'll look in between. So it sort of blocks out the crop rows, looks for weeds in between, turns on more than one nozzle so that you're covering the area that you're going after. So this is what we're using here at Ashland Bottoms. This was Isaac also up in Nebraska. They had a full-size Fendt machine with, we shrunk it the second year, 60-foot boom. The first year was like 100 foot. It was really big, but it had all these cameras on there doing the same thing and then just turning individual nozzles on and off. And we were looking at how does this work on a field size? They're using it in Europe quite a bit. It's also available in South America, more in the green on brown scenario. Our US market's a whole different ballgame, the kinds of things we want, and the kinds of things we're doing. So they're really wanting to look at how that works here. But that's, so we're exploring different programs. What if I did a residual plus a spot spray or all spot spray? How does that change my weed control and what's the best thing for my growers? So we're exploring some of those different things. More from the program side, we're not engineers, we're just running their machine to make sure that we can see what's going on. So last summer, we did have a field day and we were able to have the sprayer system come out and show us. And so they put orange dye in it. And hopefully you can see if I can run it. I don't know if I can get that done. Which one? Trying to figure, how do I get my video to run?
It went over to the screen.
The other screen, which one do
There
I
you go.
need to be on? That one. The video in there, and I'm trying to figure out where my video button is. I usually.
You have to click on the PowerPoint area.
Okay, awesome. Hopefully that works. That was part of the reason why I had to have the drive in there. Okay. Not wanting to do it, but basically, we put orange dye in there and basically as I was driving, the individual nozzles turning on and off. So, I got a different. Yeah. And so this was just showing, you know, on the ground, the area that was treated, but it would find a weed, you know, small weed, pretty small size that it could go. This was, for example, it didn't recognize that it was a soybean. It was in fallow ground, so we just sprayed it all. But this was a way just to show, you know, that it could find these small plants out there and control it. So again, individual nozzles turning on and off as it was driving through. I can play that maybe later after. So maybe, let's see if this works. Where I need to be. Run on here. But it's not showing on the screen. Okay. That's one of those, hey, you got to stop sharing and share again. Optimize for video, share sound. That's probably why. Not showing there either. Sachin gets to see it on the other screen. So, okay. So it's showing on the Zoom, but not on the power. I'm sharing. Stop share. Yeah, Sachin, thanks. Anyway, that was a web link. If you search for that, you can find a great video that shows the machine working the way we think it should be. Where's my mouse now?
It's on.
It's on the way.
I move it over here. Trying to close the video. A share back with Sachin or else he's out of luck. Don't worry, I do this in class all the time.
Okay.
After Zoom for so many years and trying
Yeah.
to teach, now I gotta find where's the mouse again. You guys see it there, it is. So, okay. Can't try anything too fancy. So one of the other aspects of stuff that our group has also done, this has been a few years back now, but we also have opportunities to take advantage of variable soils. We have a number of farmer fields that'll range in organic matter content, texture kinds of content, and as part of a full good weed management program, we should put soil applied herbicides down. And we want that pre, but they interact with the soil properties. So it's like, well, do I use, which rate should I use? Should I optimize this? how does that influence what I do in my weed management? So Garrison was a master's student, and he was interested in both soil science, weed science. How do I pull this together? And so he looked at variable rate applications of these soil products in corn and sorghum. We published data on the grain sorghum in Precision Ag Journal, but what we did was we mapped a lot of our fields to capture the variability using a Veris machine, electrical conductivity, and an organic in there, and we combined those two to tie it to soil properties. So this is an example of one of the fields that he had work on. This is near Clay Center, close to the river. So you can imagine the river probably flowing through here at different times. You don't see a whole lot of variability there. You got, some of these soil lenses and things like that. But when you put EC across there, we had quite a range from 8 to 84 units with that variability across that whole entire field. And we basically then correlated those EC values with texture and put them in different classes based on how a herbicide label addresses those. And then he looked at different herbicide rates and what kind of weed control did we get in those. So some of my advanced weed ecology students, we looked at this the other day, but way back when, dual use S-metolachlor as a herbicide had a pretty sophisticated algorithm on their label. I don't see that anymore. But basically, for the different rate in pints of the product, we have coarse, medium, fine texture, a base rate, and then you could adjust for each percent organic matter, add a little more. Because we understand that herbicides, I need more in a fine textured soil because more of it's bound up, more as it's tied to organic matter. If I need enough for weed control, I have to put enough that ties up there, plus is in the solution for weed control. And so that's where these values come in. So these are early pre-plant versus, or surface applied pre, so right at the time of planting or a little bit earlier. But again, a really nice sophisticated kind of algorithm that you can plug in for control. Don't see that on that label anymore. That was, like I said, 2004, long time ago. It's 20 years ago almost. 2016, Acuron is another product that has related product to Dual, but it has 3 others. And so I think you're starting to get too much chemistry interactions with soil to understand. But basically, it's broken up by less than 3 and more than 3% organic matter tied. So organic matter really drove this system versus all the texture variation. And so that's an important piece of what they looked at. So we were looking at Acuron using that 3% organic matter as an algorithm, and we also added texture in based on the EC data to try to look at somewhat what that looked like. So this is just one part of the field, and these are 3 reps that he laid out the different herbicide treatments in there. But you can see already from the organic matter content across these different points, 1, 2, 3, 4, and 5, that it ranged from 0.6 to 3.6. So plenty of organic matter variability. Makes sense that I change what rate I want to put out there. The EC again ranged quite a bit from less than 10 to greater than 40 based on texture analysis. An EC of less than 8 was coarse, 8 to 20 was medium, and greater than 20 was fine. So we had all 3 soil textures in there, and so we evaluated what that would look like. So again, you got that full range of texture classes. So we put treatment, a block within a common texture class to look at those product rates in there. So that's how that worked. In the end, we just did soil applied products. We didn't go in post. We wanted to see how long they lasted. Did my weeds break through because I wasn't putting the right rate on with the right texture and organic matter content? 4 weeks was great. 99, 98, didn't matter. So we used an algorithm only on soil organic matter, only organic matter plus texture, or my uniform rate, didn't matter what. 4 weeks, great. By 8 weeks, we could see it starting to fall apart. If I just did organic matter, I was getting a little less. When I had that texture piece, I could maintain it. If I went with my flat rate, I totally started to lose it. I did not have enough product there on average for what we were going in. So this was Palmer amaranth was the main weed species. You can see the densities weren't really high, but that we were getting, they were starting to come through in those different situations. So this was sort of a proof of concept. Yes, we can do this in the field, so we can continue on with more refining on how some of these work and what we can recommend. So my interest with the smart sprayer is that there's a boom there that can do this variable rate soil side, and then I can react with a spot spray post. We're not quite there yet, but it's like, that's where I'd want to go to really optimize what we're doing for our growers, is be able to match the soil on their field as well as finding those weeds that are popping up. So those are my issues with opportunities for folks in a number of different areas to all help us address these weed issues that we have out there. With that, I'll leave you with my Palmer. Little bell leaf in the middle there. That used to be my favorite weed, but you know. So as an ecologist, I have a favorite weed. And if you're in my weeds class, you usually get asked, what is your favorite? Some of that tells me a little bit about you. Because either you're persistent or you're rapid growth and you're moving where you want to be, or you got a pretty flower. I can usually tell where you're from. If I'm talking to my students in Kansas, I know where they're from. If there's certain weeds that they're worried about, whether they're east, west, or. With that, I'll open it up with that. I didn't mention. Questions, thoughts, other issues I totally missed that you were thinking I was going to talk, but I should have on my list.
Yeah. Why, when you show the graph and shows wheat is the most resistant to, why wheat is the most resistant to?
So wheat has the most weeds that have resistance. One of the things I'm thinking about is our list of herbicides in wheat is relatively low in the sense of different sites of action. So in Kansas, we have a large number of weeds that are resistant because of group 2 ALS resistance. And we have a lot of mustard species that show up in there, and almost every one of those has developed resistance. And so I'm thinking that it's I don't know, a lot of ideas. Anyone else? Talking my way through it and making sure. So one is wheat's growing in many, many places. So a lot of different weeds that occur in those wheat, limited kind of herbicide choices. So we've selected for resistance in those because we don't have glyphosate resistant wheat. We don't have really, the only trait that's resistant is Clearfield wheat, which is an ALS resistance trait. Even Monogna knows, she's looking at brome species that are resistant, and that tends to occur in wheat. And so those are dominant issues that we see. But I think part of it's where we see wheat growing around the country, around the world, and limited choices. And so most of those in that chart, the ALS was like 120 kind of potential species that are resistant to it. And I think that's where wheat comes in.
If you had to look at like an ecological of a weed, which one is like that caused more I don't know, the most difficult to feed? Let's say the quick germination, or the propagation of the seed, or I don't know, the flowering.
You need to take my weed ecology class. Those are the kinds of things that we try to talk about in there. Because each weed has its own unique characteristic to say this one is more problematic than another one. And so when I think of the driver weeds, so why is Palmer such a big issue? It's dioecious, male and female. So it's always has to cross-pollinate. So it's always adapting and can fit into its new environment. And so that gives it that benefit. Kochia, on the other hand, comes up really early. It's almost like 99% germination rate. So it's a carpet. It all comes up, no dormancy. And so it's got a numbers game that it plays. So it's like lots of individuals, you spray. I got a little guy hiding under the big guy. That little guy's going to survive. It's like, so some of that strategy of those plants allow it to do that. The tumbling action of kochia. Like I may do a great job managing it in my field, but if I go to the other side of I-80 and I've been driving on a windy day, I can see, those kochia plants rolling back and forth, and my neighbor is just giving them all the meat kind of thing. And so dispersal, seed bank life, growth, the genetic change that's always happening, those are challenging needs. I think and some of that, the propensity then to develop resistance, and how quickly that can happen. Yeah.
The last example that you changing the rates of herbicide regarding the soil characteristic, for example, like I can understand that from an experimental standpoint, right? But then how could farmers apply at different rates by having like different herbicides? Maybe
So
like having 2 different tanks, or
No, they would, just like we can do variable rate nitrogen applications. You can change the rate on the go. You can change what your rate should be on the go if you put in a map ahead of time into a sprayer and be able to then. So the benefit of maybe a soil applied map based on soil texture and organic matter, that doesn't change too much from year to year. So I should be able to get one map and be able to use that for many years. And then if I know what the right algorithm is for the rate, I should be able to plug that into my sprayer and be able to put that rate out there. And there's enough technology now with the application side to do a good job of that. Down to the nozzle. So, Sophie?
How the residue may impact on the application rate?
The residue on the soil surface. For a lot of these products, people have done a lot of work. You know, we really promote no-till, good residue layer. But we also want to get that soil applied product down there. We have not seen that there's a negative interaction. It doesn't tie up into that organic matter. We seem to be able to get it down to the soil. Some of that could be related to formulation. So instead of a liquid, you could do a granular and get it, sifting down through, but we have not seen a negative impact. Some of our students have looked at it, and I think others have too. You know, if you've got a cover crop out there, I want to both terminate my cover crop. I also want to get a pre-emergence herbicide down. We have not seen a real loss of control by having that herbicide caught cover crop. It does make it down and still get good soil control. Plus, I've already knocked back my weed population by half, and I don't have as many to deal with in that situation. So, yeah, I didn't even talk about cover crops on this one. We've done a lot of work in it. Yeah.
Calling those problems, what do you think that the farmers or the system of production are more to mix more products, to start thinking another way?
That's always a challenge. When a farmer runs into a herbicide, they probably are going to pick the easiest and most economical way until they run into a problem. Now that's painting a pretty negative picture on a lot of our growers, but the economics encourages them to go until it breaks. And then you might try something different. But we have a number of producers that are very innovative, and they see the writing on the wall. So they are thinking about multiple practices. So no-till, how can I incorporate a cover crop? How do I combine multiple different practices? We're really pushing the pre and post kind of opportunity. And if you've got a grower that's interested in the technology, they're willing to explore some of this more fine tuning of that technology. But I think most growers see, multiple tools to be able to do that. Because if, as my husband says all the time, it's going to start raining, then I can't do anything anymore. It's like, go somewhere in Kansas. But he's like, no, when it starts raining, I can't do anything anymore. And so being prepared, and we really try to help work with, I hope my students understand that as they are the ones going out to be agronomists and farmers, that we need all these multiple tools and that they're understanding all those things that need to come together. So, good question, because that's a challenge.
Because I am thinking about this relationship between the farmers and the research part. So according to that, the future of the current research lines are moving to both the cover crop and different practice and innovate together, for example.
Yeah, and so as Bosch BASF came to us to talk about some of these things, that's where I always end up. It's like, okay, what happens if I keep doing this practice on this field over the long term? Do I actually benefit, my weed population? And then how do we start tying in the other practices? They're still very interested. I just need to make sure the technology works. And they're not too worried yet about all the interaction parts, whereas I'm always going to there to make sure that we understand what those will be. And so that's an important piece. There was another thought I had, and I lost it. But yeah, they're aware that we need to do multiple things. So again, that we can build these sprayers to do multiple passes in multiple ways, and what's our best way. I know what it was. We recently did a webinar with the 4 states. So between Nebraska, Wisconsin, myself, and BASF, we brought not just the Bosch sprayer representative in, but we had John Deere See and Spray set up, as well as Green Eye Technology. There's 3 different companies out there building these different kinds of sprayers. We had a webinar that was open. We had over 500 people signed up from all over the world, interested in listening and learning about these spot sprayers. So tremendous interest. We had about 250 online in the end, listening to it live. Great questions. I was the moderator of questions at the end of that webinar, and then 2 hours, people on there the whole entire time, just really good questions. So a lot of interest in, okay, when you guys have this tool ready, how can I use it? So I'm just excited that we get to explore it and try it out and see how things are working. So awesome. Well, it's almost 1 o'clock. I ended up filling up the time anyway. So thank you so much again for your attention, and